Okay, this is Unit 1 quiz. I want to go over the answers so that way you can see what I got as the answers and why I got it that way. First question, it says here, which of the following statements is true? Well, that's a key word here. That means that they're trying to trick you, right? And see which ones are going to be false, see if you're going to mark those. We do not want the false ones. We only want the true ones. Students can clean up spills as long as they have the teacher's permission and instruction. Okay. Next one. Eating in the lab is permitted as long as the students first obtain permission from the teacher. I'm going to let you know right now, from what I can remember regarding all of our labs, there is only one lab where you would actually have to eat something because we're trying to measure the sugar content. But other than that, no. We absolutely do not ever eat in the lab. Like, it's like not okay. I understand it's permitted as long as the teachers, we have the teacher's permission. No, don't come in with your breakfast, because I know this is an 8 a.m. class. Don't come in with your smoothie. I prefer you to not even drink in the lab. Okay, again, we do not know what's going on or what's been in there. Now, there's two lab rooms that we are in normally. We're in one where we normally do all of our lessons, and then there's another lab room. Okay, absolutely, you do not eat in the lab. Next one, flip-flops. The word flip-flops, I'm going to stop there. Absolutely, we will not have flip-flops on. Hopefully we get to make it back to the school so that way I can show you. I think it's important for you to be actually in the lab, so that way you can have that experience. But no, you cannot wear flip-flops. Chemicals can be smelled directly. The key word there is directly, which makes it incorrect. The only one that's going to be okay is going to be that one. Okay? Like I said, there is one lab here that we actually do some chewing, but we don't even do it in the actual lab itself. Okay? Not in the lab. We do it in the classroom, but not in the lab. Okay? Next one. It says here that you're going to use the NFPA symbol, which is the diamond, on the right to answer the next questions. Let's see. What is the red section? Well, whether you had this or not, and this is black and white, it's not even colored, but the red section in the NFPA symbol stands for flammability. All right, flammability. The next question. The next question, we are going to use that symbol. Here's the symbol as a reminder. This is what it looks like. While you're looking at it, let me read the question. What is the reactivity rate for this substance? What is the reactivity rate for this substance? The reactivity rate for this substance is serious. Serious. The next question. The next question that we have here, again, we need to look at that same symbol again. Black and white is not colored. What does the special code, right? The special code for this NFPA symbol stand for? That special code stands for an oxidizer. An oxidizer. The next one here, we have conversions. We're converting from kilometers to meters. Really quick, you're going to hear me say this all school year long. King Henry drinks utterly delicious chocolate milk. I like to quickly just go ahead and jot that down. Then in this case, I can see that I'm going to go from kilometer to regular meters. I have a lot of students that get it confused and they try to go to this M. The M stands for milli, which is a prefix. Meters right here has no prefix. No prefix is the base unit. Okay, so kilo, you start here, 1, 2, 3. What direction did I move? I moved to the right. Find your decimal, 3.2, here it is. Move it 3 places to the right, 1, 2, 3. Fill in the bubbles with 0. 3,200 meters is the correct answer. Next one, centimeters to millimeters. Well, here's centimeters and here's millimeters. You're going to move from centi to millimeters, one direction, again to the right. Here's my decimal, move it over one place. 2.3 becomes my new answer. 2.3 is my correct answer. Next question is matching. Here we go. We've got the functions of what they're used for, and here's the actual lab equipment here. So the first one, used to heat up a substance, is going to be your Bunsen burner. The next one, used to find the mass of an object. Again, do you see the word mass? It does not use, we do not use the word weight. We don't use the word weight because weight and mass are two different things, and in science class we use the word mass. Why mass? Because we want to find out how much matter that object contains. So here we're going to use an electric scale. The next one, used to pick up hot substance or hot glassware, tongs. Then the last one, used to crush solids into smaller pieces, mortar and pestle. There we go. Those are the correct answers. There was two extra words there, graduated cylinder and beaker, and they were not being used at this time. Next question, continue to go through it. It says, regarding heating materials in the laboratory, which of the following statements is not true? Okay, so they want to know which one is incorrect. Use tongs when transferring hot objects. That is actually true, so that's not the correct answer. Work with chemicals that produce gases and vapors only in a well-ventilated area. That's actually true again. The next one. When heating chemicals in a test tube, point the opening of the test tube away from yourself and towards others. Oh, whoa. I was about to say true, but away from yourself is true, but towards others is incorrect. And when heating chemicals in a test tube, point the opening of the test tube away from yourself and others. So that's correct. The correct answer here, which is what we're looking for, the one that's not true, is this answer, right? Don't point it towards others. The next one, reactions that produce toxic gases should be performed in a laboratory with all the doors closed? No. Beakers with a lid on the top? No. Under the fume hood or a well-ventilated area in the lab? Yes. In a warm, airtight location? Nope. There goes our correct answer. The next two questions again are going to be conversions. Really quick, if this was me, I would always go ahead and jot down King Henry drinks utterly delicious chocolate milk. That way I can get ready to do my conversions. I'm going from liter. The word liter has no prefix. No prefix is what we call the base unit, which is right here. To milliliters, here is the milli. We're starting here. We're moving this direction to the right. 1, 2, 3. 0.12. Move that decimal 1, 2, 3 to the right. My new number becomes 120. Milliliters, which is right here, and deciliters, which is right here. I'm going to move now to the left. How many places? 1, 2. Here's my decimal. It's invisible behind the last 0. Move it to the left, 1, 2, 2 places. My new number becomes 25 deciliters. Okay, we need to be able to convert fairly quickly throughout in science class, throughout the whole school year. Let's keep going. The last few questions of the quiz. Says here that your lab partner was trying to be funny and broke a test tube that she was heating. How should she dispose of it? Sweep it up and carefully put it in the trash? You would think that would be the correct spot to put it, but we actually don't just put it in the trash. What about the custodian crew? What happens when they come in at night and they pick up that trash bag out of the trash can? We don't want to harm them and have them cut themselves, okay? Plus, you know, we don't want them to have any reaction. Number one, we don't want them to cut themselves and bleed, but we don't want them to have a reaction to whatever we were heating up either, okay? So that's definitely not going to be the location to put it. Eat the pieces so that there's no evidence of the broken test tube. No, that's going to be wrong. The next one, sweep it up and put it in the broken glass box. And this is correct. The reason why is because of the box. There is a glass box in the laboratory. I will definitely show you where that's at the moment we actually get to go in, because broken glassware happens all the time on accidents. And we put it in the box. That way the custodian crew knows not to pick it up and not to touch it. And us, the professors, we actually dispose of it properly after the box is full. Then we'll get another box out. All right. We don't want it in a trash bag where it can poke through. Okay. Which of the following pieces of equipment is the most accurate? Oh my goodness, they use those words. Most accurate. The moment they use those words, your brain does not think beaker. It does not think graduated cylinder. It immediately goes to a burette. The word most accurate. If they use the word just accurate, well then in that case, we're going to think graduated cylinder. We're still not going to think a beaker. A beaker is not accurate at all. A beaker is just kind of like a guesstimation. Imagine whenever you're cooking and you have those in your kitchen, you have those little scoopers that say 1 cup. I mean, you scoop it up, whatever it is, let's just say sugar or flour, and you have it in there. That's an estimation of 1 cup, okay? I don't know exactly how much I have in there. So the correct answer here is going to be a burette. Okay. Actually, I don't think that one was on the quiz, to be honest. All right. I left that one off. I went ahead and put this one in. What does MSDS stand for? MSDS stands for Material Safety Data Sheet. All right. MSDS. What does the blue section, and that was not actually on the quiz either. So I took off those 2 questions prior to you taking the quiz. MSDS stands for Material Safety Data Sheet. Everything has MSDS, including water. I know it sounds silly, but water is a compound, right? H2O. So compounds, we're going to have an MSDS for these objects or these things that we have compounds of. All right. Other than that, those were the answers for the quiz. I will put the answers for the lab video up shortly as well. Okay. Thank you.